approach on Jfet, which is a junction field effect transistor. Mainly the junction field effect transistor is used for low power consumption. As a SNS college, we are following the design thinking approach and taking the one application Jfet in the remote areas. Mainly the Jfet will be used in power consumption. Many transistor we are seeing nowadays, BJT, MOSFET and JFET we are used, but compared to many transistor, the JFET plays a vital role, where JFET has the scalability and power consumption and efficiency also be improved compared to the bipolar junction transistor as well as MOSFET. In industrial application as well as in many education purpose also, as well as for project as well as in research purpose, the JFET plays a vital role. As taking the JFET, we are going to discuss in a design thinking approach in the 5 stages. First, we can analyze about empathy, define, ideate, prototype and test part. We can have a discussion of a few minutes on 5 stages and we can start the presentation. Okay. Link use பண்ணிருக்காங்க.
அந்த லிங்க் அந்த ஃபோனுக்கு இது கண்ட்ரோல் பண்றது.
ஸ்மார்ட் ஃபோனோட கனெக்ட் பண்ணி யூஸ்
பண்ணுங்க. ஃப்ரெண்ட் ஒருத்தன் என்ஜிபி.
Let's see about the empathy part of this topic. Basically, in design thinking, empathy is the first and most crucial phase of the process. Its primary purpose is to deeply understand the people who have designed for their emotions, their motivations and their experiences. Let's see about the users who are all involved in this topic. The environmental scientists who deploy the sensors in the mountains or the forest, and farmers who lead long-term soil or water monitoring in the remote regions, and the disaster response team need the off-grid sensors, and the wildlife conservationists monitoring the behavior of the animal in the remote regions, and the NGOs implementing the tech in energy scarce remote regions. Let's see about the users' needs, what they are expecting for. They expect the devices that work without the regular maintenance, and the long battery life, and the energy harvest support, and the reliable operations in the harsh and even in the variable environments, and the minimal power consumption even in the standby method, and the affordable and it's easy to replace the components of these devices. Let's see about some of the research methods, how to define these research methods. Let's take the interview with the field observers and the remote technicians, and the field observation and the second research and the power rated failures in the remote electronics, and by studying the existing analog low power circuits and their solutions.
Next, let me discuss about the define part. The main core problem of our is that in this current generation, that the sensors using are consumes high power and not high maintenance required. So we use alternately for JFET devices for the low cost maintenance. So we have raised one question about that. If we have a low cost chip, it can have a high maintenance or not. So let me take an example in remote control areas such as forest areas. In forest areas, for controlling the measures in humidity and temperature, the forest officers can fix the sensors in the forest and come back. So it takes us a time period for about 12 to 6 months to change the battery level. Alternately, we can use the JFET devices. If we can use the JFET devices, it can wake up the next stage. So when the temperature is above the particularly 35 degrees Celsius or 25 degrees Celsius, we can standardly fix it. So after the standard reaching the standard value, it can wake up the next stage. So using the JFET devices, we can sensing that we can implement it in low cost and the battery consumption is low. So it can be used efficiently, and the workflow is from the using from one stage to another stage by waking up when they required, using the sensing of the JFET device.
Okay, let me share some of the ideas based upon the topic we have discussed. In that, we need to design a JFET based amplifier for high gains and low power consumption, and power grading techniques. These power grading techniques are used to reduce the ideal power consumption and low voltage operation. By designing the JFET circuits in a low voltage operation, it also used for reducing the power consumption. And energy harvesting techniques, connecting the JFET circuits in energy harvesting techniques such as solar vibrations, etc. and pulse-based operations. By integrating this pulse-based operation in JFET circuits, where it only consumes power whenever it is only necessary, and sub-threshold operations are used in JFETs for ultra-low power consumptions. And JFET-based switches, designing a JFET-based switches, basic switch or low powered switches are used for a controlled flow of power. And by using this, we have a longer battery life and high autonomy and reduce the maintenance.
Prototype part, we build a small test circuit using Jfet to show how they work in low power devices, which we kind of used in places where the changing battery is hard, like in mountains or in a forest. What the prototype does means takes tiny signal from something like the temperature sensor or moisture sensor and uses Jfet to handle the signal without draining much batteries. And the whole circuit runs under a small tiny battery or a solar panel, which lasts for years. And why Jfet? It uses uses no current at the gate and no current at the gate, and it is perfect for just listening the signal without draining the battery. And what is in the prototype means a Jfet to read the signal, and has a few resistors to keep the current super low, and a tiny power source like a coin cell, and maybe a tiny output to send the signal whenever they are needed. And the goal is to we test this setup and to prove that it works well, sips power slowly, and in the areas where changing batteries is hard.
About testing, the test phase is about evaluating your prototype in realistic conditions and gathering feedback from the users, realistic representative users or actual users. And for testing about deploy prototype in a small garden or forest area or rooftops to simulate the realistic conditions about the remote conditions, and observe and measure the power consumption over days or weeks, and observe and gather feedback from the users. And get feedback from potential users, like devices used potentially for the remote conditions, like data reliability and their longevity and
Scalability.
Likewise, and ask them about to reduce the frequency of your site visits over the period of time, and this would be the statement that would be helpful for complete testing.
By using the designing approach, we have built a low power energy consumption circuit by using the JFET, where it is used on the hard climate conditions and also in the rural areas where the consumption of power is very less, and it is also used in the research purposes, for example, collecting the data of the weather, climate, and soil textures. So it will be useful for the types of that sector scientists for getting the data and categorizing it and giving a proper solution for us. So it is also a futuristic approach where we are using it in all the desert areas and all the forest and other places where it is useful for us to collect the data from very harsh climate also. And now we are using it in Mars and all the extraplanetary places where it collects the data of the particular place and gives the data to us. And for our state example that we use in our area is where Rajasthan and Kerala, after the famine that is occurred in Rajasthan and the most known flood, that is 2018 flood that occurred in Kerala, by using that we can predict the weather forecast before itself. It will be useful for us to predict the climate and help the humanity.